All right, so let's get started here. So you can see that we were talking about decimal places, and decimal places we did that in the last class, but we have some unfinished business with it, right? And in decimal places we were talking about, you see we have a number here, 305.07315. Let me just hope that, right? So you can see that we have 5 decimal places here. Yeah, and we do not consider the whole number when you're usually talking about decimal places. We don't really care about this 305, right? Only the number after the decimal places is what we're looking at. So you can see, just to recall, that to 2 decimal places, this number would be 307.07. And of course, we have to check the number after. If the number is not 5 or above, you leave the number just so. We had to check the 4 decimal places, 305.0731. You check the number after the 1, we see that is a 5, so you have to round up. So 0732. So this is just a little recap of rounding up, because now we're really talking about here is significant figures and what is the difference between decimal places and significant figures. And so you can see I have the same number here, 306.07315. I have a whole bunch of zeros after the 5. So when we come to the decimal places, any zeros that you have after the last number, those don't really matter. And of course, we know in the whole number that any zeros you have before don't really matter, right? Because this is 306. If you have $306, if you put zeros before that, no matter how much zeros you put, you will still just have $306, right? So this number contains 8 significant figures. You can see the blue figures here, 1, 2, 3, 4, 5, 6, 7, and 8. So we count in the whole number and the decimal place all as significant, right? We consider the whole number as well. So to 3 significant figures, we just start from the whole number, 1, 2, 3. And same thing with decimal places. You check the number after, it's less than 5, so it'll stay how it is, 306. To 6 decimal places, 1, 2, 3, 4, 5, 6. You check your number after is less than 5, so it'll be 306.073. To 7 significant figures, we will have 306.0732. Right, because the 1 would be the last one, 1, 2, 3, 4, 5, 6, 7, and of course the number after is 5 or greater. But to 2 significant figures, this is where I had to take a look at, right? Because that we would start here with 1, 2. This would be the second significant figure. You see the number after is greater than 5. And so we would have to increase that 0 to a 1. But we can't just put 31. No, remember, with the whole numbers, this 3 and this 1, that is, those are hundreds and tens. So we have to make sure this 0 here is significant, right? So any zeros that you have before the decimal place, right? You see before the decimal place right there? And before these numbers here, right after the decimal place, or before these numbers here, and you see these zeros are definitely significant, yeah, because that's the difference between $300 and $3 million. So to 1 significant place, we're starting with the 1, we have the 3 there, and we look at the number after is 0. So we keep it at 300 to 1 significant figure. So just a little bit of business there. You can see we have a very easy question. Consider 42.371, right? Of course, the question gave it with all of these zeros in there, right? How many significant figures in the number? Well, just 5. 1, 2, 3, 4, 5. Express the 3 significant figures. Well, that would be 1, 2, 3, and we check the number after, which is greater than 5, so 42.4. Express the 1 significant figure. Well, this is the only significant figure there. and the number after is less than 5, so that would be 40. So now this is really what we're talking about here. This is percentages, right? And you can see we just use this little symbol for percentages. And percentages are fractions out of 100. So these, as you can see, numerator, denominator, they're all out of 100. So 23 over 100, that's 23%. 32 out of 100, that's 32%, right? This makes it easy to compare different fractions, yeah, as 100 always represents the whole. So you can see here that 15% could be seen as 15 over 100, right? Just remember the word percent, the word cent meaning 100. So per 100, 15 out of 100. A fraction as a percentage. So to convert a fraction to a percentage, as I say, percent per 100, so you just find that fraction of 100. So 3 out of 5 as a percentage would be 3 out of 5, of 100, or multiply by 100, which will be 300 over 5. You multiply in numerators, the denominators, and then that gives you 60%. You have 4 over 13 as a percentage. You just multiply by 100, so 4 times 100, 13 times 1, 400 over 13, that's 30.76%. 5 over 3, we can see that this is an improper fraction. So the 5 is actually bigger than the 3, showing that the numerator is bigger than the whole, right? So the denominator being the whole is 3. So that 5 multiplied by 100, we get 500 over 3. So because this number is greater than the whole, an improper fraction would represent something larger than the whole. So we get more than 100%. We get 166.66%. So it is possible to get more than 100%. And these are simple questions in terms of following fractions as percentages, right? So these fractions here, we want to convert them to percentages. So you have 2 over 3. And 2 over 3, as I say, you just multiply by 100 over 1. So that gives you 200 over 3. Yeah, 66.7%. You could also express it as in a fraction in terms of 66 and 2/3%. That is also possible. 8 over 15 multiplied by 100. So 8 over 15 as a percentage gives you 53.33%. And you can see an improper fraction here, 21 over 7. So remember, you're just multiplying numerators, multiplying denominators, and so you get 2100 over 7. So that's 300%. Yeah. So you can definitely see that the whole is 7, right? And we have 3 times more than 7 up there. So finding the percentage of a quantity. And we do this all the time. Find 15% of 200. You know, you work for $200 for the week, and the government had a tax 15% of it. So you feel you're going home with 200, but no, how much you're really going home with? And what is 15% of 200? Well, remember 15% being over 100. So it'll be 15 over 100 multiplied by 200 over 1. I mean, we know how to multiply fractions. And we can see here actually that we can cross multiply it. Right? Cross cancel these zeros. 15 multiplied by 2 gives us 30. Right? So that means that $30 would be given to the government in tax. Just remember, the word of in mathematics basically means multiply. Anytime you see the word of in any question of any kind, you should be thinking multiply, right? And so we have some questions here that we took a look at in the class. And the thieves stole. Now you're going to see different styles of questions that require you to think in different ways. And so the whole point is thinking about that 100% and asking yourself what represents, what in the question represents 100%. It might not be what you think, right? So for example, thieves stole 15% of all shoes in a store. If they had 450 shoes, right, how many were stolen? So the thieves stole 15% of, seeing the big of there, that means multiply, all shoes. So remember, 15% of all the shoes. So in this case, all the shoes are 100%. That is all the shoes. And we have 15%, so 15 out of the 100. So that is 15 out of 100 multiplied by the total amount of shoes. What is all shoes? So this here, 15 out of 100, that is 15% of all shoes, 450. And so we can see they went with 67.5 shoes. Of course, it have many ways to do this. You can cross cancel over here and then just multiply your numerators and denominators. What I chose to do via the calculator was to just divide the 15 by this to give you 0.15, multiply that by 450 with your calculator, of course. So there are many ways that you could just multiply numerators and denominators and then do the divide. So there are many ways to go about it. Number 2, remember, try to think about what represents the 100%, right? So I got 12% discount on a dress that cost $149.99, $149.99, right? So the 12% discount on a dress that cost this. How much did I pay for the dress? So 12% discount means that on a dress that cost this. So this would represent the full amount of the dress, right? And we want to find what is 12% of that, right? So 12 out of that, if that represents the full amount, right? So 12% of, and you're seeing it again, mathematics is a language, 12% of the price of the dress, right? And punch it in your calculator, that gives us $17.99. And of course, this is the discount you're gonna get. And so the price of the dress, or the cost price, minus the discount, will give you the selling price, $132. Now this is in the class here, this one causal, it pause a little bit. And remember what I told you, you have to decide, or you have to make sure you know what represents 100%, right? So I paid $20 for a dress after a 10% discount. Yeah. What was the original price for the dress? So I paid $20 for a dress, but that's after the discount, and the discount was 10%. So what was the original price for the dress? So what represents the 100 here, right? The original price for the dress is what would represent the 100 in this case. Yeah, but we don't know that. So you can see I just have it as a X here, right? So X, that is the 100%. But how much did I pay for the dress? I paid $20 for the dress after a 10% discount. So that means that $20 is really 90% after the 10% discount, right? Yeah, that is how much I paid. This is the original price at 100%. We minus 10% and we reach 90%, which is how much I would have paid, which is $20. And so now you know that 90% is $20. You find for 1% being 20 over 90, and then 100% being 20 over 90 by 100 to get $22.22 for the original price. A car depreciates, or it loses value by 10% in a year, right? If the Honda is valued at this in December, right? What was the value in January? So you know we have January and we have December here, right? And we see that after a year it loses value. So whatever value it is in January, it's gonna lose value by 10%, right? By the time it reaches December. Yeah. So so that means that we could consider January to be the 100%. And so that when it lose value, in December, it would be at 90% of the original. And so we can see here that this is the price in December for the car. And so this is the price in December for it. And so this price would actually represent the 90%. The 100% is what we want to find, which is the price of the car in January. And so by the same method we used in the last question, if 90% is this price, then 1% would be 125,000 over 90, and then you multiply that by 100 to get the 100%. This here is the original price in January. If I buy a hat for $20, I could resell it for, right? So you can see we're dealing with percentages that could be greater than 100. Yeah. So you imagine you buy a hat for $20, yeah, and you sell it for $30. So you make a profit. How much profit you make? You make a $10 profit. But what percentage profit did you make? Right? So imagine this here. This is our block, a little visual way to kind of see it. This block represents the original $20, you know, and we could cut that in half, 10 by 10, right? And so when you sold for $30, what happened is you made back the $20 that you paid for it, and you made an additional $10, right? So you made half the amount of the original price that you paid for it, yeah? You made half of the original or the cost price. That is what you made here. You made half of the cost price. And so you made a 50% profit, because this is 50% of that cost price. And so you made 50% profit on the cost price. Yeah, you made 50% more than what you paid for it. And so similarly, if you sell it for $20, right? So you have, say, so not sell it for $20, sorry. You have it, you buy the hat for $20 and you're selling it for $40. Sorry about that, right? You can see that, okay, your cost price is $20, but when you sold it for $40, you make back the cost price, but then you make another $20, right? Because you're selling it for $40. Yeah, so this red here is what you sold it at, right? And so you made back the cost price, and you make back the cost price again. You make back the full 100% of the cost price. Yeah. So in this case, you make 100% profit. And if you sell the hat for $60, well, guess what? You bought it for $20. And when you sell it for $60, you'll make back the $20, but then you'll actually make another $20. So I make 100% profit there. And then another $20. So that is 200% profit there. And so you can see that the profit that you make came as a fraction of the cost price. And sometimes it was even more than the cost price. Yeah. But this is why we came up with this formula here. The profit percentage is the amount of profit that you made, right? divided by the cost price. It is a fraction of the cost price multiplied by 100 over 1 to give you the percentage. So the percentage profit is just the fraction of the cost price. And we could see some examples that we talked about here. All right, so we have the example here that you bought the hat for $20. Right? When you sold it for $30, what is the percentage profit that you made? Well, we have the profit percent formula, which is profit over the cost price. Right? And so when you sold it for $30, you made $10 profit. Right? Over the cost price of $20. It's a fraction of the cost price. That is the profit that you made, right? Over 100. Not over 100, multiply by 100 over 1, 50%. Right? You can see here that we have $20 profit over the same $20, and so that's how you got your 100% profit there. When you sold it for $60, it was $40 over the $20, multiplied by 100, and that's how we got the 200%, because we made $40 profit here when you sold it for $60. Remember, you bought it for $20, right? You sold it for $60, so $40 profit. A shoe was sold for $500 and made 20% profit. What was the original price before the profit, right? So the shoe sold for $500 and they made 20% profit. So what was the cost price, right? Before the profit, right? So this is one of those things where, you have to realize the original price is the 100%, right? Because what you're talking about here is you're talking about after the profit. So that profit means you make more. So if you think about the original price as 100%, then that profit will be 20% above the 100. So that is 100%. That's your cost price. That is, you make back your 100, right? Plus 20% profit, right? And so in terms of percentage, that is 120%. This is what represents the new value. The new value there, that is what the shoe sold for. This is what you sold the shoe for, and the shoe sold for $500, right? So that is 120% at $500. So 120%, that represents $500, and so we could find for 1% being 500 over 120, and then we could find for 100% being 500 over 120 multiplied by 100 to give us $416.67. A cake sold for $240, but this time we sold it at a 20% loss. So what was the price before the loss? Yeah. So remember, you have the price. So you sold it at $240, but that is after a 20% loss. 20%. So it was a higher price, and then you make a loss of 20%, and now it's a lower price, right? So we can see here that if we treat this as the 100%, well, then this price would represent 80% after a 20% loss, right? So you have the 80 is equal to 240, so 80%. That would represent our price at 240, and so we could find for 1%, and then we could find for the 100%, which is the original we was looking for in the first place, and that gives us $300 was the price before the loss. Our runner ran a distance of 500 meters, 20% more than yesterday. What distance did he run yesterday? So that is interesting, right? So today he ran 500 meters, right? Which is 20% more than what he ran yesterday. Yeah. And so you can see that if we take what he ran yesterday as 100, today we can see that he ran 20% more than the 100, 120%. would represent 500 meters, right? So remember, as I said in the beginning of the video, it's all about what you decide to represent 100%. What represents 100%? Because you can see sometimes the 100% is the thing that you're trying to find, right? And you might have to go even more than 100% with the information that you have. Yeah, so 120 represents 500 meters here, and so we could find for 1% being 500 over 120, and 100%, which is the original price we want to find, not the original price, sorry, the original distance that he run, right? 500 over 120 multiplied by 100 over 1, and that gives us 416.67. A toy was sold at a 30% loss for that. So this is the price, $29.99, right? This is what it was sold for, and then we had the original price, and we sold it at a 30% loss. Notice the little visual there, right? So we can see that if we say that this is the original 100% price, well, then this would be 70%. And so this $29 would represent 70%, you know. And again, it's just the same working. You find for 1%, yeah, 29 over 70. And then you find for the 100%, 29 over 70 times 100 over 1 to give you the 42.84. So it's really just about what is the 100%, because a lot of students who just read in might probably just take this as 100%, or you might even try to find 30% of this, you know, but no, it's not just that. We had a nice little one here. This was a true or false, and true or false, 30% of 80 is equal or the same thing as saying 80% of 30. Is that true or false? Yeah. Well, the answer is true. 30% of 80 is equal to 80% of 30. And this is the reason why. The reason why is because you can see we have 30 over 100 times 80. So that's 30% of 80, right? These are fraction multiplication. You can see on this side, 80 over 100, 80% of 30. So fraction multiplication. And remember, if we have 30% of 80, right, fraction multiplication, 30 times 80, and this is it right here. And over here we have 100 times 1, that's your denominator, right? Remember, multiplication is commutative, so that means I could flip these two numbers here and I could have 80 times 30 instead, and it would be the same thing. That is what multiplication being commutative means, that they are the same, right? And so you can see that I could split back up these fractions now, and look, we are 80% of 30. Yeah, so because multiplication is commutative, makes this true, which is kind of incredible when you think about it. Now this here is a question that often comes in your paper 1. And the question is, what percentage of 40 is 80? And you will see here that this question is, the problem with it is the wording. Be careful with the wording. And what percentage of 40 is 8? A lot of people would want to go and just find 40% of 8. But no, that's not it, right? They're asking you what percentage of 40. So what percentage of 40? So you see how maths is a language, is 8. And so because we could have it in a little bit of algebra, we could use a little bit of algebra here to figure it out, right? And by doing that now, we could divide by the 40 to get rid of 40 on both sides, right? Or you can see how we did it here, right? What percentage of 40 is 8? So if you multiply the 40 by the x, you have 40 times x over 100 times 1, which is 100, right? So 40 times x over 100. I could multiply both sides by 100, so the 100 will cancel from here because I'll multiply both sides by 100, and then I'll have a multiply by 100 on this side, right? And so you could have 800 here, right? So now you have 40 times x is equal to 800, and now to get rid of the 40, you divide by 40 on both sides, and you could just have x is equal to 20%, as you could see there. Now this is a little bit of an algebraic way of working about it, of thinking about it. And so if you don't quite grasp it yet, don't worry, we will be starting algebra in a couple of classes, and so we'll definitely come back to this. As I say, this is a question that we're going to see a lot, and they're not even gonna change the words, man. They're not even the numbers. Everything is just gonna be the same, right? So just be careful with it. There's a little bit of algebra there, but we'll definitely come back to it and look at it more in depth, right? And of course, we just took a look at a final question here, and so that is we see here that 100% of people is not known, but we know that 30 people is 15%, and we've been doing questions like this all class, so 15% would represent 30, and so you could find what is 1% by 30 over 15, right? And then you could find for 100%, 30 over 15 times 100, and you can see that 100% relates to 200 people. Yeah. And so this was a brief class on percentages, and you will find it in the Google Classroom along with the computations 2 PDF. And so the computations 2 PDF does have some questions in there, and you could take a look at the next video to see some of those questions, right? So take it easy. I'll see you in the next class.